So imagine you're building an AI assistant that needs to remember everything you ever taught it, from long documents, research papers, or even notes scattered across multiple files. Now, you wouldn't want your assistant to go through all those documents every single time you ask a question, right? It would be like asking a librarian to read every book in the library before giving an answer. And that's where vector store in LangChain comes into play. They're like the memory banks of AI system. So far in this LangChain journey, we've talked about how to load data and how to split it into smaller manageable pieces. We've also seen how to generate embeddings, those numerical fingerprints that represent meaning rather than just words. But once we have all those embeddings, we need a place to store them efficiently and a way to search through them intelligently. And that's what a vector store does. You can think of a vector store as a smart semantic database. Instead of storing plain text, it stores those high dimensional numbers, vectors, that capture the meaning behind the text. So when a new query comes in, the system converts it into an embedding too, and then compares it with the stored vectors to find the ones that are most similar in the meaning. So even if your query doesn't use the same word as your data, it can still find the right answer because it understands what you meant, not just what you said. So, for example, if you ask who is known as Captain Cool, a traditional keyword search might not help unless that exact phrase exists somewhere. But a vector store contains, or the vector store understands that Captain Cool is semantically related to maybe Mahendra Singh Dhoni because their embeddings are close to each other in vector space. That's the real power of vector database. They let your AI think in terms of meaning and not in terms of matching words. So in LangChain, we can use several vector stores like Faiz, Chroma, or Pinecone, among others. In our case, in this video, we're using Chroma, which is lightweight and works perfectly for local experiments. It stores all those embeddings persistently, so even when you restart your application, your AI doesn't forget what it has learned. And when you connect this to your retrieval pipeline, everything falls into place beautifully. The documents get embedded, stored in the vector database, and when a user asks a question, the system fetches the most relevant chunks. Not because of matching keywords, but because of the shared meaning here. So those retrieved chunks are then passed to your language model as additional context, helping it generate accurate and informed answers. So vector stores are one of the key reasons modern AI systems feel so intelligent. They make your assistant capable of remembering, reasoning, and retrieving information just like a human, instantly recalling the most meaningful pieces of information it has seen before. And without vector store, your AI would simply be guessing. And with them, it's reasoning based on the memory. So in short, we can say that vector stores turn static knowledge into searchable understanding, giving your AI a memory that's fast, scalable, and deeply semantic. So now let's go for the implementation of such vector store. Okay, so I'm going to create a new folder again here. Let's call this folder 11. Call it vector store. Okay, inside this, I'm going to create my first file, vector store.py. So let me use the LangChain Hugging Face embeddings. So for this part, so LangChain Hugging Face embeddings, let's also import Chroma, which is our vector database that we are going to use. So I don't think I've imported this. So let me install pip install LangChain underscore Chroma. And I'm also going to mention it on the requirements. So LangChain underscore Chroma. From LangChain underscore Chroma, import Chroma. Once it is installed, the error will then go. Okay, Chroma. Then we'll also import document. So from LangChain dot schema import document. Okay. I'm also going to load my Hugging Face credentials here. So from .env import load.env, and load.env function is called. Let me define my embedding model here. So I'm going to copy this from my previous code. So this model will be used as Hugging Face embedding. I think we've already used this in our previous code too. So this is not new for you. So here I'm going to create some document. Let me just copy these. These are too longs for me to type. So I have some document related to some IPL players. So let me just copy this and then use word wrap. You can pause the video and then see what is being typed here. So now document 1 contains page content related to Virat Kohli and his team called Royal Challengers Bangalore. Document 2 is about Rohit Sharma and his team. Document 3 is about MS Dhoni and his team. Document 4 is about Jasprit Bumrah and his team. And then document 5 is about Ravindra Jadeja and his team. So these are the documents that I need to store in my vector embeddings. So here what I'm going to do is I'm going to combine all of this in a single list. So doc1, doc2, doc3, doc4, and doc5. Okay, now let me initialize my vector store. This will come from Chroma here. Chroma, and inside this I need to define my embedding function. My embedding function will be my embedding model that I've defined. My persist directory, let's just name it ChromaDB. A new folder called ChromaDB will be created in my project, and then my embeddings will be stored inside that. Then after that, I'll need a collection name. So the collection name will be sample. Now, since my vector store is initialized, and now I'm going to add my documents to the vector store. So vector store dot add documents, and then I'm going to add the collection of documents that I've created here. So what else? Let me retrieve vector store dot get, and then let me use some including words here. So embedding should be included whenever I retrieve from vector store. Document should be retrieved whenever I fetch from vector store, and then metadata should be retrieved. Okay, now I will have my query here. Let's say who among these are bowlers. So I have some players here, or cricket players. Among them, my query is who among these are bowlers. So what I'm going to do is I'm going to run a vector search. So vector store dot run a similarity search. My query will be my query here, and then I will fetch a top 3 result from this particular query. So, and then store everything in result, and then let's print out our result here. So let me run this. My documents will be embedded using this embedding model here, and then be stored in this vector database. And from that vector database, I will simply run a query and then run a similarity search in that query, and then get the relevant result here. So let me see. The first one, Mumbai Indians, Jasprit Bumrah is a bowler. That's nice. The second one, Mumbai Indians, Rohit Sharma is also shown as a bowler, and then the third one, Ravindra Jadeja, is also shown as the bowler. So Virat Kohli and then MS Dhoni are excluded from these search list, and then based on the similarity, it's found that Rohit Sharma, Bumrah, and then Ravindra Jadeja are bowlers here. Let me also run another query here, if it's okay. We can also do something like this. So we can also print our result based on similarity search with scores. So if we see this, then we should see that the result Rohit Sharma should have a very low similarity score here. So similarity search with score. Okay, our query will be our query, and then we'll have a top 3 result here. So let me run this again. Then we should see that the similarity score for Rohit Sharma should be quite less than Bumrah or Ravindra Jadeja here, because Rohit Sharma is not in fact a bowler. Sometimes he does bowl off spin, but not much. So let's see. Wait for, okay, the first one is Jasprit Bumrah. So this is shown. Okay, wait, okay, I've not printed the result. Let me also print the result. Let me omit the previous result, and then let me print it here. And then let me comment this out. And I just want to see the result with the similarity score. And then you might be wondering where this Chroma DB is. It should be well within here sometimes. So yes, you can see the folder called Chroma DB, and then using that particular Chroma DB vector database, my result is being pulled here. So Jasprit Bumrah has a similarity of something like 1.01. So again, it's saying Jasprit Bumrah, and then it's saying Jasprit Bumrah again. So the top result is only Bumrah, and then not the other bowlers here. So this is how vector store works. It converts our data or documents into embeddings and then store it, and then based on the query we have provided, we can fetch following contents, as well as what we can do is we can get the most similar result, or like run the similarity search on our given query against the stored documents. So I hope you understood the concept for vector store. It is just like a database, but instead of storing your data, it stores the embeddings of your documents. So this is all for this video. If you have any questions, do comment down below and I'll try to help you out. And I will see you in the next video.